Hello, my name is Andy, and thank you for joining our first webinar. Today, I'm going to talk about 5 common web attacks and how to protect your system from it. It's probably very basic knowledge, but I will try to make it easier for those who want to start protecting their network. So, the first question you might ask would be, why these 5 web attacks? What's the criteria? I picked up this list from OWASP Top 10, the most recognizable institution on web threats. These 5 web attacks are the most common and high risk or growing threats. However, it may be easy to stop them as well. First is ESCO Injection. First found in 1999, still effective and high risk attacks. ESCO injection has a lot of variation, which increases the risk of intrusion. Second is Crosssite scripting. Crosssite scripting set a record on the highest occurrence rate in 2017, rating the high-risk web threats in OWASP Top 10. Third is DDoS, simple but effective attack. Fourth is Malicious Bots, applicable in various ways and high growth rate. Lastly, SSL exploits, increasing uses of SSL traffic causing security issues. Let's start with ESCO Injection. ESCO Injection is an attack using the language SQL that communicates between web server and the database server, as described below. The user and the web server communicate using HTTP, and the web server takes the information from the database server and delivers to the user. These attacks use the SQL language that the database understands, so if the database server understands the SQL statement, it will deliver the result to the user directly. Therefore, there are variations on these attacks such as data insertion, inquiry, and deletion, as well as authentication bypass. In order to understand this more clearly, let's have a look at database system and login process. When using a login on a web server, the user sends a request value and the required data is inquired by the web server to the web database server. As you can see in the below diagram, if the web service needs to accept all request values, such as login attempts, the user should be allowed to receive the data or block them. The web server inputs and receives the data received from the user in the specified SQL statement. Then, the database sends the result of the corresponding value to the web server to process the contents. Assuming this as a login attempt, the user with permitted account will receive the login success, and unauthorized account attacker will receive the login failure result. This is a diagram of what might happen when ESCO injection attack is performed. Using attacker account that is unable to log in, an attacker can bypass authentication by using a simple SQL bypass syntax of attacker or 1 = 1. Attacker will insert a double quote to close the original SQL statement to initiate the attack as 1 = 1, resulting the database to unconditionally allow the attacker's intention. Thus, with a very simple syntax, an attacker can bypass the connection. You can also exploit the database server to execute the statement by inserting the correct syntax into the SQL grammar, just like the way that bypassed the login. In the following diagram, we enter the statement to delete the table, which is the location where the data is stored among the SQL statements. The drop table is passed to the web server, and the web server deletes the table with the contents of their corresponding value. Of course, commands such as input, modification, and so on can be performed in the same way. The above is blind ESCO injection attack, one of the attacks derived from the basic ESCO injection. The blind ESCO injection attacks are often used to gather information. The attacker will perform ESCO injection or other web attacks based on the collected information. This is called Blindness Connection because it is used when the database message is not visible to the attacker. The difference between ESCO injection and the blind ESCO injection is whether or not the messages are visible or not. But if ESCO injection is a way to allow the attacker to perform the desired actions directly, blind ESCO injection can be used to determine whether the result is true or false. Therefore, when the attack is performed, the information is collected based on the reaction of the server. For example, if the uppercase A is 65, the uppercase B is 66, and the lowercase ABC is 97, 98, 99, the attacker will request the number to check the server's response. Because there are no characters, the database server will not react on the 66 and the 97. Based on these results, the attacker can guess the name of the data is ABC. Although the below diagram are described as one by one, in an actual attack, a lot of values are transmitted using the automated tools to collect the information with combination.
Next is Crosssite scripting, also known as XSS. Among the 5 web attacks, XSS is the only attack type that targets the client, not the web server. There are mainly 3 types of attacks: persistent type, non-persistent, and DOM attacks. XSS is a formal attack that inserts code into a web server to make it behave in an undesirable manner. Therefore, in order to insert code into a web server, attacks are mainly performed in a place where data is freely stored, such as bulletin board, but attacks can be performed in various ways. While the web server is processing the uploaded post, the attack is executed according to the executable script, the XSS attack script. Because of the nature of the script, a wide variety of attack types are constantly found. Secondary attacks can occur using the information gathered through Crosssite scripting. XSS attacks are mainly used in web servers that upload articles, such as social media or bulletin board. The uploading is not only simple, but it can also expose the attacks to many users. The first XSS attack I want to introduce is called Persistent XSS technique, or Stored XSS technique, where an attacker inserts a post and an XSS statement in the same place, such as web server bulletin board, and when a user reads the post, attacker would claim and override the user's connection information, authority, and management. The XSS content from the user may not be noticeable because it is mostly not visible to the naked eye. The technique is very aggressive because when an attacker uploads an XSS, all subsequent users are attacked at the same time. This is because the content is permanently stored on the server. Any user who connects to it will be attacked unless XSS is deleted on the server. Therefore, attackers can perform XSS attack for a long period of time. The diagram on the left shows it is called non-persistent XSS technique or reflected XSS technique. Attackers who are already aware of XSS vulnerability of the target server will send out URL information containing XSS attack code to the users. The user clicks the URL to perform an XSS attack on the target server as the attacker wishes. It is difficult to identify the attacker because the attacker does not directly execute the attack on the server. You can also deliver URLs that contain XSS attacks through other means, such as emails or advertising, rather than a web server post. Therefore, there may be no record on the web at all. The diagram on the right is called DOM XSS attack technique or DOM XSS attack technique. This attacking method is very similar to non-persistent XSS. The attacker sends the URL to derive the users to connect. When user connects to the web server prepared by the attacker, malicious file will be automatically downloaded and executed. Similar to persistent attack, attackers can control or override the users by making them download malicious file. DDoS is one of the most common web attacks. This is because the attack method is very easy and simple. As its name, DDoS depletes the system resource to disable the server from its service. There are a variety of attacking techniques such as HTTP flooding attack, which transmits a large amount of HTTP requests, SYN flooding attack or SYN flooding attack sending a large amount of SYN packets used in session connection, and even occupying all the network line by using massive network sessions. However, since DDoS requires a large number of requests to perform the attack, normally it uses zombie PCs. This diagram shows the basic format of DDoS attack, in which an attacker sends a very large number of requests to the server, making it impossible for ordinary users to use the web server. If an attacker sends a lot of normal requests to web server using many zombies of bots, the web server itself cannot distinguish the attacker and the normal users. In addition, web services that do not have downtime can suffer lethal damage because these types of attack tend to last a long period of time. Also, the server and any additional network lines or appliances can be down, which may cause secondary damage. SYN flood attack sending large number of TCP layers SYN packet, or GET flood or HTTP flood attack sending large amount of default HTTP request or GET method, or SSL flood attack sending large amount of SSL communication request or HTTP sessions can also be applied in the same way. Since most of the DDoS attack occur in layer 3 and layer 4, there are various ways to defend it. However, if a DDoS attack occurs in layer 7, the application layer, defense technique gets really difficult. One of the variation attack targeting web application is brute force attack. Brute force attack is an attack method that accesses the account login with different password combination until it succeeds, hijacking the login account. The web server or database server can also be down with brute force attack. The bot is a computer, not a normal person, that connects to a web server like a person. Not all bots should be blocked, since websites like Google or Baidu uses bots in many ways, such as marketing purposes or for testing web services, but some attacks uses bots to upload malicious file and attack the web service. Since the criteria for distinguishing bots and people are increasingly obscure, defense is difficult and thoroughly prevented. Mostly, an attacker makes a bot that is difficult to distinguish from a person and attacks the target web server. Attacks include data theft, uploading malicious file, XSS, ESCO Injection. Thus, malicious bots allow attackers to perform a wide variety of attacks. Advertised fraud is one of these variations. Advertisement fraud does not target the web server, but upload advertisement to redirect users to malicious server or reduce the reliability of the web service. An attacker can use a bot for web server forgery by scraping the web server. Fraudulent servers are very difficult to distinguish because they use the same page structure, image, and the text content downloaded from the real server. They may contain malicious files and attack normal users. It can also use payment page to collect personal information. This is also a very dangerous attack that can lower the reliability of the web server by misleading the normal users to copy the server instead of the original server. Let's have a look at typical normal bot, like Googlebot. In the case of normal bots, the type-block web servers are investigated in advance to provide search services or even check for malicious activity. These bots contain bot name in every request data through user agent, so you will know it's actually not a person. However, there are also malicious bots disguised as normal bot, so it is important to have a protection protocol. As use of web services has greatly increased for the past decade, the importance of security has also increased accordingly. HTTPS is one of the first protection methods. HTTPS uses SSL encryption communication with HTTP, which is an existing web service protocol, so only the server and user can check the contents. As shown in the below diagram, the contents of the normal data on the left are encrypted as shown in the diagram on the right. It is widely used as it is very important, and recently it is known that Google's Chrome will set a warning, such as warning about sites that do not provide HTTPS. However, there are many security vulnerabilities founded in SSL, which often leads to a failure to provide basic security. If an SSL vulnerability is found, the attacker can intercept the data that can only be verified by the server and the user, which can cause verification problems. Most security vulnerabilities occur in open source SSL libraries that are actively used in the market. There are also cases in banks, payment systems, etc., where the security is extremely important. One of the SSL vulnerability is called Poodle. First found in 2014, an attack using the most vulnerable SSL, version 3. You need to understand the basic flow of SSL communication first. The most secure communication among SSL communication is TLS version 1.2, then TLS version 1.1, TLS version 1.0, and SSL version 3 in that order. A typical computer tries to communicate from TLS version 1.2, which is the highest and the safest communication. If the communication fails, it will automatically attempt to communicate with lower version. Poodle is an attack mechanism that exploits this communication flow. The attacker disables the user to access with TLS version 1.2. The user and the server, without the attacker's acknowledgement, retries the connection with low version until it connects with SSL version 3, the lowest security. Then the attacker decrypts the contents to read it. Sensitive information can be leaked in this way because the level of encryption is low enough for an attacker to see the contents. It is very dangerous because the user cannot easily find out that the attack is going on. Another vulnerability is called the Drown vulnerability, discovered in 2016. It is one of the attacks very similar to the Poodle attack just described before. It is one of the attack methods that reads the attack data from the general user by using the lower SSL version. The user and the server are not aware of the attack situation at all. Currently, SSL version 2 is officially stopped supporting and forbidden from using. However, when the Drown vulnerability was first discovered, about 33% of the entire servers was still using SSL version 2. Drown attack is a very simple method. The attacker may first request the target server to communicate with SSL version 2. If the target server supports all SSL versions, including SSL version 2, the connection will only be made through SSL version 2, the most vulnerable SSL version. Then, the attacker may use SSL version 2 to decrypt and copy the key values that are very essential for TLS communication. When the key value of the server is stolen, the communication between the user and the server can be 100% decrypted, meaning that the attacker may have full access to the data. These attacks are obviously targeted to the servers that still supports SSL version 2, drastically increasing the dangers of encrypted traffic. Here is another example. This attack is called Heartbleed attack. It is one of the most famous and dangerous attacks of SSL attack, also founded in 2014. This attack can be used in communication itself, regardless of the SSL or TLS version. It is a technique that exploits the heartbeat used for SSL communication. This vulnerability was found in OpenSSL, one of the SSL open source libraries. Heartbleed attack uses the state check signal of a server called heartbeat in SSL communication. When users send and receive the data to confirm the server's SSL status, the data is exchanged and according to the length. Attacker will use the heartbleed to connect to the web server using the heartbeat signal like the diagram. When the attacker requests reply good 4 characters with 200 characters, the server will deliver the word good and the remaining 200 characters to the user. In this case, this 200 character the server replies might include a lot of very important information, such as the status of the information of the server. If the attacker grasps this information, they can use this to attack the server for additional information or decrypt the entire server and communication content. Okay, so we reviewed the top 5 common web threats. As you can see, these attacks are similar in some ways and different in another. The attack may differ on the purpose as well, which means there are numerous ways to protect them. Here are some of the protection methods. Let's start with SQL injection protection. The first step to prevent SQL injection is to block the SQL query command execution. As mentioned earlier, SQL injection is performed because the web server and database server can understand the contents. Therefore, it can defend most forms of SQL injection by preventing the command from execution. For example, if a SQL query type is entered on a login screen, you can restrict most attacks by limiting the input. Second, you can block special characters in URLs or input boxes, as special characters are used to complete the SQL injection. Thus, simply blocking the special characters can be a good way to defend SQL injection. Third, remember all communication type between web server and database server, and to block all communication that's not compatible. This method is the best way to block SQL injection. Since most of the source code of the web server communicate with database, most forms of communication are fixed. The surest way to block the attack is to block any visible miscommunication with full acknowledgement of this communication structure. In case all the above protection didn't work, you were infiltrated with SQL injection, what you want to do is to set a web server's database server authority to the minimum. If the web server is compromised, the attacker can delete or change the information on the database, causing secondary damage. However, If web server authority is limited to insert or select, the attacker will only be able to write or read the data, although that was the original purpose of the ESCO injection. In order to prevent cross-site scripting, the first step is to block the input of script type values. As the name implies, XSS is a script, so it has a specific form. Therefore, if all the forms are prevented, the script can't be executed, which means even if the attacker enters the script, the attack will not occur. Second, it's the same as preventing a ESCO injection described above. By recording all the operation in the web server, this can only be done when the source of the web server is fixed. If there is an operation inconsistent with the stored content, the operation will be terminated. The third is to limit the number of input characters in the input box. Since XSS is a script, it requires a large number of characters, definitely more than 10 characters. Therefore, if you limit the number of characters to a very small number, let's say less than 10 characters, the script cannot be executed. However, this can be difficult since web server may disallow putting limits in certain input boxes. Finally, there are methods that can be used if the web server doesn't allow the input limit. This is the most commonly used method to prevent XSS defense, known as escape string. The escape string is a way of replacing special characters that are used for XSS to different values, stopping the XSS script to be executed. Even if the user confirms the input data, the content outputs are normal. Also, you'll be able to distinguish between suspect attack and actual attack. To block DDoS can be quite simple. DDoS attempts to deplete the resource, so if you block that access, you can block the attack. When controlling the attacks, you will need to use WAF to detect whether certain request is excessive or not. Normal PC can't cause massive traffic amount as much as DDoS. For example, DDoS can request up to 100 times or more in 1 second. Simply blocking massive traffic that is impossible for normal PC means that you're blocking the DDoS. But in order to deploy this method, you will first need to grasp the state and the environment of your web server. Okay, next is malicious bots. In order to block malicious bot, you can use behavior-based policy such as CAPTCHA, honeypot, script verification, or etc. You can also authorize known browsers, since not all bots have malicious purposes. The reason for using behavior-based policy is that computer programs cannot understand the contents of the web pages. CAPTCHA, for example, bot may recognize the connection is successful because the web page is connected, but a person may understand and act on the view and enter the contents of the photo and then access the actual web page. Therefore, this is a way to distinguish a bot from a person by using the fact that computer does not understand the contents of the page. Another behavior-based policy is called honeypot. WAF can create a non-existent virtual page called honeypot URL that is mainly used to prevent bots performing an unlimited number of attempts to access various contents of the web page, such as web scraper. This is a method of judging a bot and blocking it when it accesses a page that cannot be viewed by a normal user. Finally, the first thing you need to do to prepare SSL vulnerability is to simply stop using low-level SSL. Because SSL targeted attacks are primarily targeted at low-level SSL, companies developing SSL libraries are also advised not to use low-level SSL. Secondly, you can use WAF to handle SSL communication. Handling SSL communication means that you can prevent intervention. Lastly, avoid using the open source SSL library in the server. The SSL vulnerability exploits a very large number of attacks against open source libraries. It is very easy to use and efficient as it's open to the public, meaning there are a lot of servers using it. Okay, this is what we prepared for the top 5 common web threats. Thank you for listening.